Jai Hind students. So today we are going to start a new topic which is force. We'll start with the intro, right? You all have heard about this term force. So before we start with the actual topic, let's consider some very basic facts. A body which is lying at rest, it tends to remain at rest and it cannot change its state of rest into motion at its own. What I mean to say is that, students, if a body is at rest, it tends to remain in its state of rest. If a body is in uniform motion along a straight line, the body tends to remain in uniform motion along a straight line until and unless some external unbalanced forces acted upon it. So, what does force does? In this case, the force causes the body to change its state from rest to motion. Suppose a chair is lying at rest. If I pull it or push it, then the chair will start moving. It will change its state from rest to motion. So that pull or that push which influences the body to change its state, that effect is known as the force. That influence is known as the force, right? Suppose a vehicle is moving on a road and the driver of the vehicle applies the brake. So what happens is, on applying the brake or applying the braking force, the vehicle starts slowing down and eventually and ultimately it stops. So what does that braking force does? It is making the body to change its velocity. It is making the body to change its state from motion to rest. So that's the effect of force. So students, force is an impact. It is an influence which changes or tends to change the state of rest or of uniform motion of a body. So force can either make the body which is at rest to change its state into motion, or the force can even make a body to change its state from motion to rest. It can also make the body to change its direction. That we'll discuss in separate headings. I would like to mention one more thing, students. Force is an influence that changes or tends to change the state of rest or motion of a body. It is not mandatory that on applying force the body must change its state. For example, a heavy load is lying on a floor. A heavy load, suppose 1000 kg. If I give it a push with all my energy, then also I won't be able to make the body move. So I am applying that force. I am applying the force on that heavy load, but I am unable to make the body to change its state from rest to motion. So here, although force is being applied to the body, but yet it is not changing its state. So remember, force is an influence which changes or tends to change the state of the body from one state to another state, from rest to motion or from motion to rest, or it tends to change the direction of the body. Clear, students? So once again I repeat, we'll go into the actual definition later on. As per Newton's law, it is also defined in terms of the mass of the body and the acceleration which the force produces. But we'll discuss those definitions later on in this section, right? For the time being, you need to understand that there are various types of force. Here in this particular chapter or in this particular session, we'll be concentrating only on the force that tends to change the state of a body, right? So, in that scenario, how do you define a force? Force is a pull or it is a push. So basically, force is a pull or a push. It is a pull or a push, or it can also be defined as an influence which changes or tends to change the state of a body. Tends to change the state of a body. So that is how you can define force. And what are the states of a body? The body can either be at rest or the body can be in uniform motion along a straight line. So in order to make the body to change its state from rest to motion, force is required. In order to make the body to change its state from motion to rest, there again force is required. So students, force is a pull, it is a push, or it is an influence, it is an impact, as a result of which it changes or tries to change the state of rest or motion of a body. So that is how force is actually defined, right? There are some other forces as well. There are some forces which, on applying on a body, do not result in the change in its state, but result in the change in its configuration. I'll tell you. For example, if you hold a sponge ball, right, and then you squeeze the ball, then what will it do? Obviously, the ball will remain at rest. But what happens is, when we apply force or we try to squeeze the ball, then it will tend to contract. So as a result, the shape or the dimensions of the body under consideration may change. Such a force, students, is known as a deforming force. I will give you another illustration as well. Let us consider a string or a wire to be suspended to a rigid support. This is a wire or a rod or a string which is suspended to a rigid support. This is the rigid support. This is the rigid support, right? And at its free end, a heavy load is attached. A heavy load of mass m is attached. Now what happens is, under the influence of this load, what happens is, the wire will tend to get stressed. That is, it will get elongated. Its length will increase. So, the weight of this body, which is the force, is making the body, which in this case is a wire, to change its dimension. It is getting elongated. So students, in this case, the force under consideration, which is the weight, is the deforming force. The wire is at rest, it will remain at rest. But in this case, the force, which is the weight, is making the body to change its configuration, to change its dimensions. Such a force which results in changing the dimensions or configuration of a body without changing its state is known as a deforming force. So what I mean to say is that there are various types of forces, right? There are some forces which we have discussed which tends to change the state of rest or uniform motion of a body, while there are some other forces which tends to change the configuration or dimensions of a body, right? So we'll discuss all the various possibilities. So students, basically, the influence of a force. We'll discuss the influence of a force. So we'll discuss it in 3 or 4 separate categories. Let's discuss all the cases. So, influence of a force. And here, we are dealing with that force which tends to change the state of a body, right? So, let's consider case 1. This is a body which is initially at rest and force is applied along this direction, right? So, what will happen? The body is initially at rest and the force is applied on this particular body. Let us assume this body is lighter one. So, the impact of this force is that the body which was earlier at rest will start moving along the direction of the force. So, it will start moving. It will start moving. So, in this case, under the influence of this force, the body is changing its state from rest to motion. The body is at rest, but under the influence of this force, the body is moving. It has started moving along the direction of the force applied. So this is first case. Let's consider the second scenario. The body is already in motion. The body is already in motion. Suppose it is moving along a straight path. It is in uniform motion moving along a straight path. And force is applied in the opposite direction. Consider these two diagrams, right? Here the body is already in motion, and here suppose the force is applied in a direction opposite to which the body is moving. So what will happen, students? This force will make the body to retard. It will slow down the speed of the body, and eventually and ultimately the body will come at rest. Eventually the body comes at rest. Eventually the body comes at rest. So the body will keep moving along this direction, but with retarded motion. Its speed will keep on decreasing, and eventually, ultimately, after covering some distance, the body will eventually come to rest. So these are both the cases where the force under consideration is making the body to change its state. In case A, it is changing the state of the body from rest to motion. In case B, this force is making the body to change its state from motion to rest. There are some other cases as well. Consider case C. Suppose this is the body, and body is moving along this direction, and the force is applied along this direction, that is in a direction perpendicular. F stands for the force. So in this case, the force is making an angle of 90 degrees with the direction of motion of the body. Here, students, you must remember this force will make the body to move along a circular path. This force, which is acting perpendicular to the direction of motion of the body, will make the body to change its direction continuously. And as we have discussed in the previous section, whenever the direction of a body changes continuously, it must be the case when the body must be following a curved or a circular path, isn't it? So this is the case where the body will start moving along a curved or a circular path. The body will start moving along this direction. So students, let me repeat these three. This is the case where the direction between the force and the direction of motion is 0 degree. In this case, the body at rest will start moving. In this case, what's the angle between the force and the direction of motion of the body? 180 degree. This is the force and this is the direction of motion, isn't it? So in this case, force being opposing nature, it will tend to retard the motion, and eventually the body which was earlier in motion will eventually come to rest. What is the angle in this case between the direction of motion and the force applied? In this case it is 90 degree. In case the force is acting perpendicular to the direction of motion of the body, then this force will not result in the change in the speed of the body, but it will result in the change in the direction of motion of the body continuously. And that is when the body will start following a curved or a circular path. Is it clear, students? There might be fourth case as well. There can be a case where the force is inclined at an angle theta. Suppose this is the direction of motion of the body and force is applied along this direction. So here the angle is neither 0 degree nor 180 degree nor it is 90 degree. Theta can have any value other than these three. In such a case, what happens is this force not only changes the speed of the body, but it also changes the direction of the body as well. So in this case, the body will tend to move again along a circular path, but with non-uniform speed. So it must be the case of uniform circular motion and it must be the case of non-uniform circular motion. Clear, students? These are some very, very important concepts. Again, I repeat, these are the forces which either changes the magnitude of the velocity of the moving body or it changes the direction of the moving body. So, it is an influence or an impact by virtue of which either the speed of the body changes, or the direction of motion of the body changes, or both changes, right? This is the case where the body is changing its state from rest to motion. This is the case where the body is changing its state from motion to rest. This is the case where the force applied is perpendicular to the direction of motion of the body. In this case, the body will tend to move along a circular path. We have discussed about centripetal acceleration, students, isn't it? So it always acts in the radially inward direction. The same is the case over here. So if the force is acting, so it will produce an acceleration. Because this force acting on the body will result in the change in the velocity due to the change in its direction. And whenever there is a change in the velocity, it must be the case of an accelerated motion, isn't it? So, force acting perpendicular to the direction of motion, it will enable the body to move along a circular path. And in this case, when the force is inclined at an angle theta to the direction of motion of the body, in this case, one component of force will tend to change the speed of the body, while the other component, which will act along the radius towards the center, it will enable the body to move along a circular path. So here, the body will follow a circular path with non-uniform speed. In this case, the body will follow a circular path with uniform speed. So it is the case of uniform circular motion, and it will be the case of non-uniform circular motion. Correct, students? So these are the feasible cases. Right? These are the influence of force. So again I repeat, force actually is an influence, it is an effect, it is a pull, it is a push which changes or tends to change either the state of the body or results in a change in the speed of the body or results in a change in the direction of motion of the body. So this is what we have discussed in these four possible cases, right? So now next what we'll do is we'll discuss some various types of forces. We have discussed about the force which tends to change the state of a body. We have discussed about deforming force. There are some other basic forces in nature. They are basically, I am talking about the basic forces of nature. They are the gravitational force, it is a force which acts between two material bodies. Now every body is made up of matter, isn't it? And mass, as you are aware, it's the amount of matter contained in a body. So every body is made up of matter. So any two bodies exert upon each other an attractive force, and that is known as gravitational force, right? So these two pairs, they are also exerting a force upon each other, but that is too small to be measured. In fact, the force within these two, it is almost negligible. But there exists some attractive gravitational force between these two, right? Between any two material bodies, there exists some attractive force, and that is known as the gravitational force. So this is one of the weakest forces in nature. Clear? Second, we'll discuss about electric force. Now from the term, it must be very, very clear. Electric force, it can exist only between charged bodies. You have heard that two like charges tend to repel each other. Two unlike charges, they tend to attract each other. There are actually two types of charges. It can be either positive or negative, and neutral bodies possess zero charge. So if two like charges are brought closer to each other, they will tend to exert a force of repulsion upon each other. They will tend to move apart from one another. On the other hand, two unlike charges, one positive, the other negative, they will tend to attract each other. So these forces may be either attractive or repulsive depending upon the nature of the charges. So such a force which exists between charged bodies is known as electric force. Similarly, there's magnetic force. This also you must have done in your junior classes. In a magnet, you are aware, magnetic monopole do not exist. Magnetic pole always exists in equal and opposite pairs. There are north pole and south pole, both of equal pole strength. Now when the two magnets are brought closer to each other, with their like poles closer to each other, then what happens? North-north or south-south, they will tend to repel each other. While on the other hand, if the north pole of one magnet is brought closer to the south pole of the other magnet, they tend to attract each other. So what I mean to say is that here again, like poles will tend to repel, while unlike poles will tend to attract each other. So the force that exists between the poles of a magnet, which can either be of attractive nature or repulsive nature, such a force is known as a magnetic force, right? And there is another very, very important force which we will study in higher class, that's nuclear force. As the term suggests, this is the force which exists inside the nucleus. You are aware of the basic composition of an atom? Students, an atom consists of a central positive core, which is known as nucleus, which is surrounded by a cloud of electrons which are negatively charged. Now inside the nucleus, there are nucleons, which are the combination of protons and neutrons. So between these nucleons, they tend to interact with each other with nuclear force. So it is a force which exists between the constituent particles of a nucleus, which are known as nucleons, which are the sum of protons and neutrons. So they are basically of attractive nature, and these are nuclear forces are the strongest forces in nature. So these are the four basic forces in nature. Gravitational force, it exists only between material bodies, it exists only between masses. Electric force, it exists between charged bodies. Magnetic force, it exists between the magnetic poles. Gravitational force is always of attractive nature. Electric force and magnetic force, it may be attractive or repulsive, depending upon the nature of the charges or nature of the poles. Nuclear force is basically of attractive nature, right? And remember, these are the weakest forces. Nuclear forces are the strongest forces in nature. Clear, students? So these are the four basic forces in nature, right? So since we have discussed the basic intro about force, how to define force, what impact a force can have on a body, so now we are in a position to discuss balanced forces. Again, from the term it's pretty clear. Balanced forces. Now look. Balanced forces means forces, not one force, more than one force, acting on a body which tend to nullify the effect of each other, which tend to balance out or cancel out the effect of each other. Suppose this is a body at rest initially, right? Now this body is under the influence of several forces. Like here the body is under the influence of force of 2 Newton. We'll discuss. N stands for Newton. It is the SI unit of force. We'll discuss it. It is the SI unit of force. Suppose in the opposite direction also it is being acted upon by some other force whose magnitude is same. Right? Now what happens is, under the influence of these two forces, the body will still remain at rest. Why? Because although these two forces are acting on the body, yet their effect is zero. Because these two forces being equal in magnitude and oppositely directed, they will tend to nullify or cancel out the effect of each other. So what is the net force acting on the body over here? It is zero. So net force acting on the body is zero. Therefore, the body, if earlier it was at rest, even under the influence of these two forces, it will remain at rest only. So students, balanced forces, if it is at all acting on a body, it do not result into change in the state of the body. If the body is at rest, it will remain at rest under the influence of balanced forces. Right? Similarly, if the body is in motion, suppose this is the body, and it is moving along a straight path with speed of maybe 8 meters per second. It is moving along the same direction, along the same straight path with speed of 8 meters per second. Now suppose it is under the influence of these forces. Here suppose force of 2 Newton is acting. Here suppose force of 2 Newton is acting. Here in this direction, suppose a force of 1 Newton is acting, and here again a force of 1 Newton is acting. So what happens is, these forces, they tend to balance out the effect of each other. Why? Because F1 and F2, they are equal in magnitude, each being equal to 2 Newton, but they are oppositely directed. Now look, this is a pen. If I apply a force along this direction, and if I apply the same force of similar magnitude in the opposite direction, then the pen will remain in this position only. Isn't it? In a tug of war, the same thing happens. If both the teams apply the same force, then the reference line will remain constant. The reference point will remain constant. No team will win in that case. Isn't it? It's because the forces being equal and opposite tend to cancel out. Same thing is happening over here. F1, F2 being equal in magnitude, each being equal to 2 Newton and opposite directed, they'll cancel out the effect of each other. Similarly, F3 and F4, both are of magnitude 1 Newton, but both are acting in the opposite direction. They will also tend to cancel out the effect of each other. So students, what is the net force acting over here? It is 0. No net force is acting over here. So if earlier the body is moving with 8 meters per second along a straight line, then even after the application or even after the influence of all these 4 forces, still the body will keep moving along the same straight path with velocity of 8 meters per second. So no effect. Even under the influence of these 4 forces, the body will remain in its state of uniform motion along a straight line. So these forces, which do not change the state of a body, are said to be balanced forces. So what is the mandatory condition for the forces to be balanced one? The condition is that the net force acting on the body must be 0. Then all the forces acting on that particular body may be said to be balanced forces. So students, one should be crystal clear in his or her mind that if a body is in uniform motion along a straight line, then no net force is acting on it. Clear? If a body is in uniform motion along a straight line, it doesn't mean that some force is acting on it. No force is acting on a body when it is in uniform motion along a straight line. Because if some net force is acting on a body, then it will certainly produce a change in velocity of the body, either in its magnitude or in direction or both, and that will result in the acceleration of the body. So in that case, the body can't remain in uniform motion. So that is the reason why, students, mark my words, whenever a body is in uniform motion along a straight line, then it must be under the influence of balanced forces. That is, no net force is acting on that particular body. Clear? So, how to define balanced forces then? First point, under the influence of balanced forces, the body do not change its state of rest or its state of uniform motion along a straight line. That is, under the influence of balanced forces, if the body is at rest, it will remain at rest. If the body is in uniform motion along a straight line, it will remain in uniform motion along a straight line. Second point, net force acting on a body under the influence of balanced forces is always 0. Clear? So these are the two illustrations. Even under the influence of these two forces, the body which was initially at rest, it will remain at rest because they are balanced forces. In this case, the body is assumed to be moving along a straight line with uniform speed of 8 meters per second. So in this case, the body is under the influence of these 4 forces, F1, F2, F3, F4. Since they are balanced, therefore the body will remain in its state of uniform motion along a straight line. Clear, students? Okay. Now let's discuss unbalanced forces. It's the antonym of balanced forces. Now, we'll consider a similar illustration over here as well. So, let's consider unbalanced forces. Right? So, consider first case. This is a body which is at rest. Second situation. The same body is under the influence of some force. Maybe, let us assume, this is a force whose magnitude is 10 Newton and this is a force F2 whose magnitude is suppose 4 Newton. Now students, which one is dominating one? Obviously 10 Newton is much greater than that of 4 Newton. So what is the net force acting over here? F1 minus F2 along the direction of the dominating force. So what will be the net force over here? Since they are opposite directed, so their resultant will be given by the difference of these two. So here the net force acting would be 10 minus 4. That would be equal to 6 Newton. And in which direction? Along the direction of the dominating force. So dominating is 10. So resultant force will be like this. Have I made myself clear? So here the body is under the influence of forces F1 and F2. But since their magnitudes are unequal, therefore net force acting on the body is not zero. It is having some non-zero finite value. So this body is under the influence of this net force directed along this direction. So what happens is the body will start moving. The body will start moving. In which direction? Along the direction of the net force. Actually, in this case, the body will start moving and it will start getting accelerated. Because force always produces acceleration in the body. It tends to produce acceleration in the body. It is changing its speed from 0 to some finite value. Isn't it? So it must be the case of acceleration, change in the speed, change in the velocity that results in acceleration. So in this case, the body which was earlier at rest now starts moving. So that is only when the body is under the influence of unbalanced forces. So unbalanced forces means the forces acting on the body do not cancel out the effect of each other. Instead, there is some non-zero finite value of net force acting on the body, which results into the change in the state of the body. In this case, this unbalanced force is resulting the body to change its state from rest to motion. Right? Let us consider second illustration. Suppose this is a body which is moving with a speed of 10 meters per second and a force of maybe over here 3 Newton is applied and over here 2 Newton is applied. A body which is in motion along this direction is under the influence of these two forces. Now look, these two forces are opposite directed, but they are of unequal magnitude. This is 3 Newton, this is 2 Newton. This is larger force. So they won't cancel out the effect of each other. Instead, the resultant force would be 1 Newton. 3 minus 2, 1 Newton along the direction of the dominating one. So what will be the resultant force? Like this. This is the resultant force. F net. It will be equal to 3 minus 2, that is 1 Newton. Along the direction of the dominating force. F1 over here is dominating. So, body is in this direction. It is moving in this direction. So this force, this net force acting on the body is acting in a direction opposite to which the body is moving. So what will be the influence of this force? It will make the body to decrease its speed and eventually the body after covering some distance will come to rest. So this is unbalanced force, which is making the body to change its state from motion to rest. Understood, students? So what are unbalanced forces? Whenever the body is under the influence of unbalanced forces, then it will definitely result in the change in the state of the body. The body will either change its state from rest to motion, or the body under the influence of unbalanced force will change its state from motion to rest. And second is, under the influence of unbalanced forces, there must be some non-zero finite value of net force acting on the body. So students, I hope you have understood the basic concepts of force, isn't it? So in this particular lecture, we have discussed force, the types of forces, the actual definition of force, the influence which a force can have on a body. We have discussed all the possible cases, isn't it? Then obviously we have discussed balanced forces and unbalanced forces. So students, do study these topics thoroughly, and we will continue in the next lecture then. Do take very good care of yourself, and